part today is just a review of Friday. Oh, USB device not recognized. I don't know what USB device they're talking about. I don't even know if y'all can see that. Sorry about that. I never know if when a little notification pops up, if y'all can see it or if you think I'm just talking to myself and sound crazy. So we're just going to go through all these. Don't be surprised if some of these are the same questions as on your homework. I didn't realize that was going to happen when I was looking at what they did in the past, and then I found the questions that I wanted to use as review. Anyhow, a bunch of them are the same, but pretend like you don't have them already worked out. Just try them again. All right, there. We're multiplying things with the same base. We are going to keep the base, add those powers. Common denominator is 4. So I get 2 and 5/4, which is the 4th root of a 2 to the 5th, which I need 4 of something to clean up a 4th root. So I definitely have 4 2, so I can bring 1 out, and it would leave 1 under. This one, this is 3 to the 1st times 3 to the negative 1/4. So I'm going to add up those powers. Oops. Common denominator is a 4. So we'll get 3 to the 3/4, which is the 4th root of a 3 cubed. Can't clean it up because there's only 3 3s. This one, if I'm paying attention, I can do it really quickly because I can notice, well, the 20 and the 5 are both to the 1/2 power, so why not make it 25ths to the 1/2 power? So that's the same thing as this, and that 1/2 power, remember, is the same thing as a principal square root. So it's really just telling me to do 2 cubed and get 8. Okay. If I multiply things with the same root, 2 radicals with the same root, I can just multiply. Let's see. I am going to see if I can speed this up. Of course, I don't know if it'd be any faster with this way if you didn't know this already. I know 2 to the 5th, let's start there a lot, is 32. Times 2 more, 64, so that gets me to the 6th. Times 2 more, 100. So this is a 2 to the 7th. So really, it's a cube root of a 2 to the 9th, which is a 2 cubed, which is an 8. This one, I could make it the 5th root of 192 over 6. And how many times does that go? Don't feel like thinking this morning. Of course, it helps if you punch it in correctly. That's the 5th root of a 32, which is just 2. Let's see, 500. I'm doing cube roots. I need 3 of something. I definitely have 3 5s. I definitely don't have 3 2s, so 2 squareds, 4. This one, oh, this is an interesting question. Because first, I can't do anything with the 4th root of 19. I can do something with the 4th root of 4, though. Okay, the 4th root of 4, that makes it 2 to the 2/4, which is 2 to the 1/2. A principal 4th root of 4 is the same thing as a square root of 2. However, that doesn't make it any easier, though, because then I have 4th roots and square roots. So let's try another route. Let's keep this and multiply. Well, hang on. Let's rewrite it. Because I was like, oh, that's going to make it. But it didn't. It didn't make it better because I still have that 4th root of a 2 squared. But if I multiply by this version of 1, this will look better. Because that'll give me the 4th root of 19 times 4. Let's see, 19 times 4, 76. And then that's going to be the 4th root of 2 to the 4th, which is just 2. Okay. This one, let's see, I got the 5th root of 3 over the 5th root of 4, which is a 2 squared. I want to get that 5th root out of the denominator. So I'm going to multiply by that version of 1. So 3 times 8 is what, 24? And then it'll be the 5th root of 2 to the 5th, that's just 2. Okay, multiply by this version 1. We'll use the conjugate, that denominator. So that gives me 18 plus 3 root 2 up here. 36 minus 2 down here. Okay. 7 of those minus 1 more makes 6 of these. And a 12 is a 2 times 2 times 3. There's nothing in there 5 times. This is 4 on the cube root of a 9 squared plus 8 on the cube root of a 9 squared, which gives me 12 of these cube root of 9 squareds. However, this will definitely clean up because a 9 squared is a 3 squared. So I can bring one of the 3's out, leave one of the 3's under, and end up with this. Okay, let's see. Can I clean up the cube root of 40? Oh, I can because 8 goes into it. So this is the cube root of a 5 added to 2 on the cube root of 5. So one of those plus 2 more of those. I got 3 of those cube roots of 5. Okay. All right. And then today it's working with a lot of variables. We are going to let all the variables represent positive numbers. And here in a second, I'll show you why. Because it's kind of a pain when you don't. The biggest thing with this, you've got to make sure you understand numbers are still just numbers. Like if all this junk right here hadn't been there, it's 12/24. That is still a half, just like it has always been a half. Okay. And then let's see. I think there's several ways you could do this. You might just want to bring everything to the top, to be honest with you. Like make it x to the 2/3 times x to the negative 5/3, y to the 5/4 times y to the negative 1/2. Because then if you did, then you multiply things to the same base, we could add our exponents. So 2/3 minus 5/3, that's negative 3/3. 5/4 minus a half. Okay, so now we're at 1/2. X to the negative 1, y to the 3/4. So I've got the 4th root of a y cubed over a 2x. And that looks pretty good. All right. I can do the same kind of stuff here. Let's see. I like positive exponents, so I can almost guarantee I would move that x to the 5/2 down. I'd move this x to the 1/2 up. Actually, would I just bring everything to the top? I don't know. I might just bring everything to the top. We're going to have to move all that, but I'd leave the 3 down there. And then y to the 5/2, y to the negative 1/2, and you get that z, the 2/3. So right here, multiplying things the same base, add the exponents. It's going to give me negative 4/2, which is negative 2. If I add 5/2 and negative 1, I get positive 4/2, which is positive 2. Still have this thing. So I think I would just make it a y squared times the cube root of a z squared all over a 3x squared. Okay, 64. Oh gosh, what did I really just do that? I know that 4 cubed is 64. Yeah, that's 4. The cube root of y to the 6th, that's y squared. And you want to think of it this way: 3 and 3, nothing left over. Okay, this means the 4th root of x the 4th, the principal 4th root of x the 4th over the principal 4th root of y the 8th. So that's just an x over y squared. This one, I can't clean up the 5th root of 4. However, like what if we broke it down to the primes so you can see it one time? 1, 2, 3, 4, 5, 6, 7, 8. Oh gosh, do I really want to do that? I guess I've committed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6. Okay. I need 5 of something. 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 5. All right, so what I'm going to bring out is an A, a B, and another B, and a C. It'll leave all this under. So I get AB squared C on the 5th root of 4A cubed B to the 4th. Now, once you do that a time or two, you can pretty much do that in your head. Like, you can go straight from there to there. Because you're like, okay, 8 A's. How many groups of 5 do I have? 1. And if I took that 5 out of the 8, I'd have 3 left. That's what I'm doing. Okay, so this one, let's clean up before we start. Y to the 8th. So how many groups of 3? 1, 2, 3, 4, 5, 6, 7, 8. How many groups of 3 are there? 2. So we'll bring a y squared out, but it'll still leave that under. Okay. And then if we throw in a cube root of y, then right there will be a cube root of y cubed, which is just y. So I'll end up with x on the cube root of y all over y cubed. Okay, let's see what we can do here. 14 divided by 2 is just 7. And then I've got an x to the first, x to the negative 3/4. If I pull the x's up, I've got this y to the 1/3, and I can pull this up. So, common denominator, 1 minus this 4/4 minus 3/4. I'm going to get 7x to the 1/4, y to the 1/3, z to the 6th. So I guess if I wanted to write it as radicals, I'd probably write this. Now, there's other things I could do also. I don't know if I should talk about them today or not. I guess I probably should. Like right there, an x to the 1/4 and a y to the 1/3. I could write both of those over 12. So that I could make it the 12th root of x cubed y to the 4th. You'll see a lot of people do that too. Well, this one's easy enough. Oops, 11 looks weird. And then this one, let's see. So the first one, I've got the cube root of z to the 5th. So I could definitely take a 12z out. Or sorry, 12's already out, but take a z out because 3 of the z's are z cubed. And it would leave the cube root of 2z squared under there. Okay, so I got this z out here. 54. Okay, I could bring out a 3. And it would leave the 2 and the z squared under. So I've got 12z on the cube root of 2z squared minus 3z on the cube root of 2z squared. So it leaves me 9z on the cube root of 2z squared. All right, now here's the thing that we don't do in Algebra 2 here, apparently. I checked. They told me no. I'm hoping they do it in pre-cal, but I didn't ask. Because if the answer is no, I'm going to be sad. I don't want to be sad. We don't worry about when to put absolute values when you're working with square roots and variables. Did you notice how on these directions it says assume that all variables represent, I didn't catch that, represent positive, all variables represent positive numbers. Oh my gosh, I got 2 mistakes. Crap. Well, okay. So, like we were just saying, if I took the principal square root of x squared, we were just saying it's x. All right, that is technically incorrect. It does represent x if your x are a positive number to start with. Or I guess that probably say non-negative, because if it was a 0, it would still be 0 also. But the reason why you have to worry about it is like, what if you had this? Okay. By the order of operations, I would square that -2 first. And then the principal square root of 4 is just 2. However, by me saying this, x is whatever I was squaring. According to this, I should get -2 out, and a principal square root cannot be a -2. So technically, the answer to that is the absolute value of x. Okay, I know that's tricky. If you had, say, now if it's a cube root of x cubed, it is just x, because a cube root can be positive or negative. So you don't have to worry about, like, the answer is definitely going to be positive, so I'm going to put absolute values around it. This one, the answer is definitely not going to have to be positive. It could be negative. You don't want to put absolute values there. If you did something like the fourth root of an x squared, let's say the square root of an x to the fourth, and say you're just assuming everything's positive, x squared is going to be a positive number as long as you don't involve imaginaries, and we're not. So that one doesn't need an absolute value because this answer can't be negative in the first place. So pretty much what you're looking for is to put those absolute values in there. It's the fact that whatever the variable is could have been a negative, but you can't get negative answers. So let's just try some. So like right here, if it's a cube root, you do not worry one bit. Cube root of 64 is 4. Cube root of that is y squared. You're done. You don't have to fool with anything. Okay, but see how, well, we can go ahead and do this one. Just x, guaranteed. Because you got a cube root. You don't have to worry about it. Okay? All right, this one. All right, if the variables are all positive, this would be an x over y squared, which we already talked about, right? Okay, but I could do this. I could use a negative number for x, but I'd have to get a positive. So that x gets an absolute value. Y squared doesn't need it. Y squared is not going to be negative in the first place. Okay, we just did this one. This would get me x on the square root of x if I just worried about what it is. This one, you actually don't need the absolute values because right there, x has to be greater than or equal to 0 in the first place, or else it doesn't fit the domain. Like, we don't want negatives under even-rooted radicals. Okay, this one's x squared, which we did up top. Doesn't have to, that's can't be negative. Okay, this gives me an x cubed. So this is where I got to worry about. X cubed might be negative. Could I use a negative for x? Take a negative to the 6th power is positive. Yes, I would get a positive out. This one needs an absolute value.